Hey everyone, welcome to today's coding session. Today I will be solving the longest common prefix problem in Python. I will explain the problem, constraint, and two approaches, a brute force solution and a more optimized approach. As I code, I'll explain each step in detail, including how I determine the time and complexity. Well, let's get started. So, understanding the problem. We are given an array of string, and our goal is to find the longest common prefix shared among all string. If no common prefixes exist, we must return an empty string. And for example 2, there is no common prefix among all string, so we return an empty string. For problem 1, on the other hand, we have flower, flow, and flight. And as you can see, FL is what they have in common. Flow and flow are common for this one, but because of the I, therefore they all have flow, FL, in common. Now identifying key constraint. Now that we understand the problem, let's think about the constraint. So the constraint, as mentioned here, the number of string, this means that we could have a small or large number of words to check, either 1 or 200, which is 1 or 200. And then for the length of each string here, we have 0, meaning it's an empty string, or 200. So some word could be empty and some could be quite long. And for character set, string consists only of lowercase English words, as stated here. So there's no need to worry about spaces, numbers, or special character. From this, I already know that an efficient solution is important because if we have 200 words, each 200 characters long, that potentially is 40,000 characters in comparison, or to compare. Now, thinking through the idea, I want to start with brute force. So one approach is to take the first string and compare it to all other characters by character. We keep shrinking the prefix until we find the longest match. So for example, here, as we did before, we got flower. This is the example we're going to use. And then we start with flower as the first character. We compare flower to flow. And after we compare, what we see is that flow is what they have in common because they have F in common, L, L, O, O, and W. So because of that, we're left with flow. Then after flow, and now that we have flow, we put this here, what they have in common. Now we're going to compare flow to flight. And when we compare the two, we see that the only thing they have remaining is F and L. So based on that, we're going to return F and L as the longest common prefix that they have in common. This approach works, but it might be slow because we're checking each word fully. So now let's go and code the brute force approach. So here we go. So starting, we already got the definition there. So the first thing we're checking for, if not strings, then we're going to return empty string. And the reason for that is because, as it says here, anytime you do this code right here, it means that, let's say it was an array, and the array is empty, which could be like this. Or if it's a string and it's empty, like this will always return false. If not this, it'll return false, so therefore we'll return string in this case. Saying that the only thing they have in common is the empty set, or the empty string. And now we want to go is we're gonna do prefix, store the first string in the array. And now we're going to do our first for loop in order to go through the array. In string, and we're going to go and index the string. This will slice the string starting from index 1 all the way to the end of the array. And then we're going to do temp prefix, as we mentioned in the preparation. Temp prefix is empty now because so far we don't have anything in common. And then we're going to do our second loop, which is going to be for I in range. And we want to pick the minimum length string. So let's compare the length of the prefix to the length of the current string that we're comparing it against. So here we're going to compare prefix, which is the first string that we selected out of the array, to the current string, which at this point is at index 1, and whichever one is shortest or minimum length, we're going to use in order to iterate through the string. So if the prefix I equals string I, so now we're just comparing string by string, and if they're equal, we're going to update prefix. We're going to update prefix with the current value of prefix I. On the other hand, in the event that these strings right here that we're comparing are not equal, then we're just going to break out of the loop. And then after we're done with the loop, which is going to be completely done, then we are going to initialize prefix. Not completely done, just done with this loop. We're going to do prefix equals temp prefix. So now we started off first with the index 0 string. We compare the index 0 with index 1, and whatever they had in common, we're going to add to this prefix. And then we're going to move on to through the loop again. We're going to go to the next index, and we're going to do the same, and we're going to update the prefix based on that. At any point as we go to the string, as we pointed it out previously, we are going to end up shortening. So we're going to start off with a long string, and it's just going to shrink it down as I expressed as I was thinking through the idea. Now last, if prefix equals, so when we go through this, if prefix equals at all after that, the empty string, then we're going to return the empty string. Because as we shrank it down from the index 0, which may be the longest word, and then we went through each index, we found out that, let's say the first one, the index 0 and index 1 had something in common, but then when we go to index 3, it has nothing in common with the previous two. Therefore, we're going to have an empty string, and that's why we're going to return an empty string in this case. Now, after we finish the whole loop, if there is something that they all have in common, we're going to return that prefix. So I'm going to give an explanation again for the brute force. So let me break this down step by step. Check if the input list is empty, as I said here. That's the first thing we're going to do. And if it is empty, we're going to return the empty string. Initialize the prefix with the first string, as mentioned here. Then loop through the remaining strings, which is what we're doing here. We're using this string right here, allows you to slice through an index. So we're able to get the next index starting at 1 in this case. Then we're going to compare character or prefix with the corresponding character in the current string. So again, here is where we're doing a comparison, and we're looping through it. We're going to use the minimum string. Then we're going to store the matching character in the prefix here to keep track what they have in common. And then if a mismatch occurs, we're going to stop the comparison, and then we're going to update prefix with what we currently are tracking that we have. So then if prefix becomes empty at any point, we return the empty string. And then at the end of, once we're all done, we'll return the longest common prefix found. And now going over the time complexity here, let's analyze the efficiency of this approach. The time complexity of this approach is big O of n times m. N is the number of strings, and m is the length of the shortest string. In the worst case, we compare m characters for all n string, which gives us the big O of n times m. And what this means is this first for loop is going to go through all the indexes of the string, which would be this right here. So we're going to go through all of that. How many lists are there in the array? And then in the second for loop, we're going to go through this approach over here, which means we're going to go through each index. And in worst case scenario, we're going to go, let's say they all have the exact same letter. Let's say it says test, test, test are the 3 index. In the worst case scenario, we're going to go through all of the string, substring, as we index through it. And this is what we're getting. So that's where we get the worst case scenario, a big O of n over m, or n times m. Now in regards to complexity, in this case the space complexity is O of m. We store the prefix, which in the worst case is as long as the longest string actually. So again here, the complexity, which all we're seeing is, are we using up more memory? And we may end up using more memory because what we're storing here is the prefix that they have in common, which is m. It could be, if it was test, 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 m is the longest string that they have, and that's the space that we're using. So now let's implement a more optimized approach. So just thinking through, first before I do this, before I do the most optimized approach, let's see if I have any errors in my code. Let me run it, see how it compares, if it passes the test cases. So you can see it does. Test case 1 and test case 2 return the empty string. And let's see how it compares to others. As you can see, 3 milliseconds, so it's pretty fast, but it only beats 36% of other people's code. Very fast, but not as fast as it can be. Okay, so now let's think through how to come up with an optimized approach. So instead of shrinking a prefix, another way is to check one letter at a time across all words. So for example, again, as we did flower before, this is going to be our comparison one more time. So we got flower, but this time instead of putting them side by side, we're going to put them vertically. So this will be more efficient by doing so. So now when we compare it vertically, we're going to go through F, and we're going to say, does F is the same as this F? And if that's the case, which it is in this case, then we move on to the next one, and then we compare these vertical column. Is L the same in them? Yes. If that's the case, now we move to the other one. Is the third index, or 0, 1, 2, is the second index the same? And we know that this is the same, but not here. So therefore, when we do this, what we're going to do is we're going to compare, and we're going to realize that only FL is what they have in common. And that's what we're going to return. So this is more efficient because we stop checking as soon as we find a mismatch. And now looking at edge cases to consider. A good developer thinks about edge cases before coding. So let's consider a few of them. One of them is that all strings could be the same. So as I mentioned before, it can all be test, test, test. And in this case, it's going to be O, a big O of n times m, n being 1, 2, 3, the number of strings in the array, and m, the length of the string, which at worst it can be 1, 2, 3, 4. So that's how we get the 3 string and 4. So O times m being 12 in this case. Now another condition is that there is no common, there's nothing in common for them. So A, B, C, D, E, F, G, H, I, for example. So there's nothing in common here, so we're going to have the empty string. Then another possibility is that one of the string itself is just empty. So right off the bat, we're going to return the empty string because one of them is already empty. So we know they have nothing in common as well. And only one string in the list alone will be another option. And that option is this. Like let's say we just have GHI. So now that we thought through the problem logically, we are ready to start coding. So instead of checking an entire word at once, we will check one character at a time across all strings. The moment we find a mismatch, we stop. So let's start coding this. So if not string, as mentioned before, we're going to return the empty string because we know that either they have nothing in common. Actually, in this case, there is just an empty string there. And therefore we return the empty string. And then for I in range of len string 0. So in this case, now we're just getting the length of the first index, and then we're gonna go and index it. So in this case, we're not even storing it at all. We're just simply getting the length of it, and we're gonna start from 0 all the way up to the length of that string. Then we're gonna store that first. Now instead we're not storing. All we're gonna store is just the character of the first index. So now we got the first string out of the array, and then we're indexing now. We're getting each individual character of that string now. Now that we do that, now we're going to create another for loop, and here we're going to compare it to the other strings in the array. So if I is greater than or equal to the length string, or string I does not equal char, now we're going to return string current string up to I. Otherwise, we're just going to return that they have the entire first index as the answer. So here's what happened in this approach. So the first thing, as mentioned, we're looking for an empty string. If it is empty, meaning the array is empty, then we're going to return that they have in common the empty string. Then we're going to iterate through the first string. We're going to save the first index or each index individually. And then for each character position I, we're going to compare it against the ith character of every other string, as I showed in the example as I was thinking through how to solve this problem. If any string ends or has a different character, we're going to return the prefix found so far. And that's what we do here. And if all characters match in all strings, which in this case, as I mentioned, test, 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 then we're going to return that original 0 index prefix. So now thinking over the time complexity, the time complexity still is the same. As we know here, we're going through the end list, and we're also going through worst, as we said, test, test, test being an example, array, each one having 4 letters inside of them. That would be three array, for example, 3 strings, and 4 in length for each one will give us 3 times 4, 12. And in this case will be big O of n times m. So the complexity is still the same. So if a mismatch, the only benefit here is that if a mismatch occurs early, we stop quickly. Where on the other one, we actually may go through more of the string and then shrink it. So in regards to space complexity, in this case, space complexity is order 1. And the only reason it's order 1 is because here, the only thing we're storing is just simply the index of each variable one by one. So space is not really increasing that much. Whereas in the other ones, we were storing the entire first index. So we only use a few integer variable, which will be ichar, and no extra storage. And then comparing both approaches, as we said for the first one, the time complexity is O of n times m, which is the same as the brute force, and the optimized approach are the same. The space complexity for the brute force is O of m, because in that case we were storing, it could have possibly been the biggest string in the whole list. Whereas in the optimized approach is O of 1. So both approaches have the same worst case complexity, but vertical scanning stops early when possible, making it more efficient in practice. So let's see if this code runs, if I have any issues. Okay, so for I in range, length string S. See if any other issue shows up. Okay, so it passed the 2 test cases again, and it most likely will return the same level of accuracy, a couple of milliseconds. In this case, it's 2 milliseconds, and it's slightly better than the previous one. So there's still a more optimized approach to this. But I just gave you 2 efficient ways of solving this problem. So in conclusion, what we covered today is we started by understanding the problem statement. We implemented a brute force solution and analyzed the complexity. We then improved it with a more optimized approach, a vertical scanning. Finally, we compared both solutions in terms of efficiency. I hope this walkthrough helped you understand the longest common prefix problem. If you found this useful, don't forget to like and subscribe for more coding tutorial. See you next time.